Hello again. Today we're going to be learning lesson 40, which is all about using the power rule. So it's giving us another rule to use for exponents. We've had the product rule, our power of zero rule we've talked about, and now we're going to see the power rule. So things we've already seen, our product rule says if I have something, just for quick review, product rule tells me that if I have something that looks like x to the power of 2 multiplied by x to the power of 3, we would have a product because it's multiplication. It's just going to be x to the power of 2 plus 3. That's our product rule. Looking at some other things, we also have our power of 0 rule. Power of 0 rule, which tells me that x to the power of 0 is going to be 1. Anything to the power of 0 is 1. And we also have our negative exponent rule. Which is going to say that anything to a negative exponent is going to be equal to 1 over it to a positive exponent. And x to the negative 3 would be the same as 1 over x to the third. What that also means is that x to the power of 3 is equal to 1 divided by x to the negative 3, just as a little side note. But moving into what the power rule actually is. So the meat of today's lesson is going to be the power rule. Love this rule, doing it in bright red, making it nice and powerful. So what if we have something like 3 squared to the power of 3? So this is a power of a power, raising an exponent to an exponent. A lot of inception going on. Well, we know what 3 squared is 3 times 3. So what I'm going to do here is taking this and raising it to the power of 3. So what that gives me is going to be 3 times 3 times 3 times 3 times 3 times 3. And now looking at this, I have let me erase that. I have 3 groups of 2. I have 3 groups of 2. What I'm going to end up with, if I count, I got 1, 2, 3, 4, 5, 6 threes. Same as 3 to the power of 6. That's nice. Let's try another one, see if we can find a pattern. So I'm going to try 4 to the 5th squared. We're going to try to find our pattern here. So 4 to the 5th is 4 times 4 times 4 times 4 times 4. That's a lot of 4s. I'm going to square it, which means to multiply it by itself. 4 times 4 times 4 times 4 times 4. If I count these out, I end up with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 4s. So this is the same as saying 4 to the power of 10. So looking at what I just said, I said that if I have 3 squared to the power of 3, I end up with 3 to the 6. I also said that if I have 4 to the 5th squared, I end up with 4 to the 10th. So we should be starting to see a pattern a little bit. And what we end up finding is that if I have something, I'm going to call that something x, and I raise it to a power, let's call that power a. I'm going to raise that to another power, let's call that b. I'm going to end up with x to the power of a times b. So looking back up here, that means that 3 would be our x, 2 would be a, raised to the b would be 3. Should end up with x, so our x is 3, x is 3, 3 right here. 2 is a, so it's going to be squared, and b is 3 times 3. 2 times 3 is 6, 3 to the power of 6, which is what we got. We can also do that with 4 to the 5th squared, should be 4 to the power of 5 times 2, which is 4 to the 10th, which is also what we got, so that's a really good thing. Moving through this a little bit more, we have some other examples I would love to look at. get a little bit of extra room, we can also have more complicated things inside of our parentheses here. So what happens if I have 7a cubed b to the 5th all to the power of 3? That looks really complicated. So we're going to write this out to see what it looks like. I end up with 7a cubed b to the 5th times 7a cubed b to the 5th times 7a cubed b to the 5th. Nice thing about multiplication, I can rearrange it however I want. So that's the same as 7 times 7 times 7. Now I used all those, don't need to worry about those. Going to rearrange all my a's next. It's going to be times a cubed times a cubed times a cubed. I've used all my a cubes. And then I'm going to bring my b to the 5th out next, times b to the 5th, times b to the 5th, times b to the 5th. So all I did there was rearrange the multiplication. So we had right here 7 times 7 times 7 times a cubed times a cubed times a cubed times b to the 5th times b to the 5th times b to the 5th. So I rearranged that into this, and what I end up with is 7 cubed times a cubed cubed times b to the 5th cubed. So what happened was this exponent right here got applied to all three of the parts of our multiplied portion inside of the parentheses there. It's kind of like the distributive property, but we don't call it that because the distributive property is only when we have things added inside the parentheses. But essentially, the exponent here got distributed into all three parts of that. So what we end up with, I'm just going to call this 7 cubed. It's going to end up being a really big number. That's okay. 7 cubed times a to the 3rd to the 3rd. We're going to multiply those. 3 times 3 is 9. Gives us a to the 9th. 5 times 3 is 15. It's going to give us b to the 15. So we end up with 7 cubed a to the 9th, b to the 15th. Alright, let's try another one just to make sure that we have this down. Quick example would be 3 into the 4th squared. Again, we can bring this inside to both of these. We get 3 squared into the 4th squared, which would end up with 3 squared and to the power of 8. So 4 times 2 gives us 8. 3 squared is just 3 squared, and that's how that would come in. As a last bit, our last example for this, we're going to have simplifying some expressions. So simplifying expressions. And my example expression here is going to be 4xy squared squared times 2x cubed y squared. And I want to simplify that. So the first thing I need to do is I'm going to take these squareds right here. I'm going to bring them into my equation. So the 4 is going to be affected by it. I end up with 4 squared. My x is going to be affected by it. I end up with x squared. And my y squared is also going to be affected by it. So I have y squared squared. I do the same thing over here. End up with 2 squared, x cubed squared, y squared. So I simplify this. I end up with 4 squared is 16, x squared is just x squared, y squared squared would be y to the 2 times 2, which is 4. Multiply that by 2 squared, which is 4. X to the 3rd squared is going to be x to the 3 times 2, which can be x to the 6. And y squared is just y squared. Moving on even more, we can now combine these two. I have x squared times x to the 6th. So 2 and 6 That's going to be our product rule because we're multiplying them, so we just add these together. 2 plus 6 is 8, so we have x to the power of 8. Y to the 4th times y squared. 4 plus 2 is 6. I have y to the power of 6. 16 times 4 is 64. So that's going to be my coefficient out front. And that right there is going to be my final answer. What I would like you guys to do in your notes, besides just having notes of what we covered in this video, is to also try the practice problem. 9ab to the negative 2 squared times 2a squared b to the 4th. And if you have that at the bottom of your notes, you will be good to go. I'll see you guys in class.